Alright, so in class you guys have got to look at, and you've seen this start off with these quantum numbers, you've got to be able to break this periodic table down for you to get your answers whenever you're dealing with giving me the 4 quantum numbers for the periodic table, and to work backwards if I give you 4 numbers, determine an element. So it all is based off this periodic table. So first thing we're going to deal with, by now you should know the S block, P block, D block, and the F block. Alright, how are we going to start breaking these things down? First thing, we'll start with the S block. S block's simple. It's when you wish you had an assistant. Go Garrett, leaving stuff up on the board. Alright, so first thing, if L is 0, 1, 2, or 3, that looks horrible. Let's do it this way. So if L is 0, 1, 2, 3 tells you the block. So if it's 0, it's S, 1 if it's P, 2 if it's D, and 3 if it's F. So in this will tell you what you need to be finding, and from here you should know, using your angular momentum quantum number, L, you can find the range for your magnetic quantum number, which tells you your orientations. So in this case, breaking down the S block, there's only one orientation for the S block, 0. So first column off the periodic table, 0, and the second column, 0. That's all it is. Then, break it down. The first column is your first electron you put in there, so it's a plus 1/2. And the second column is a negative 1/2. Remember, helium, for our case, if you're ever finding the quantum numbers for it, is like it's right here in the S block. It is not in the P block. So let's go to the P block now. Starting with the P block, if you work backwards, you'll find out the orientations. You have 3 orientations. Okay? Your orientations are always negative L to L. So L for P is 1, so we start with negative 1. The P block starts in the 13th column. So you'll start in the 13th column with negative 1, 0, and 1. That's for the first. It repeats. I think these things that stick up. So you'll get negative 1. 0 in the 18th column is 1. And remember, for your spin quantum number, your first part is a positive 1/2. That is columns 13, 14, and 15. Once your orientations repeat, then you change the sign for the spin quantum number. So 16, 17, and 18 is a negative 1/2. So let's just keep moving on. Let's go to the D block. My gosh, there's a lot of these. Hopefully you remember you have 5 orientations. Sweet God. Just stuck us down there. That was a smart thing to do. So D block, D block starts in column 3. So you're going to start off with it going through. If you're dealing with the D block, L is 2. So the range for your orientations are -2 to 2. So just start it off. Column 3, -2, -1, 0, 1, and 2. Let me get these. You're in the video. Way to go, Chase Brown, to the rescue. Thanks, dude. Go ahead. I'm up to 4. All right. So, starting back in the D block. Repeating again, your orientations. -2. -1. 0. 1 and 2. Remember, you start with the up arrow, which is the positive. So columns 3 through 8 is the plus 1/2 for the spin quantum number. And then -1/2 is 8 through 12. Alright? Then you're going to go into the F block, which is a confusing area for everybody out there. I understand. Depends what periodic table you're using, what you're going to see. So I'm just going to use this one for an example. This is the technique you will find for breaking this thing down. So, breaking this down for your quantum numbers in the F block. If it's an F, then you know L is 3. So the range is -3 to +3. So, start with the first column in the F block. So right here, if it's lanthanum, just start there. It's okay. Okay? But the correct one would be cerium. But let's go -3, -2, -1, 0, 1, 2, and 3. That's how you'll break it down. You just keep rolling. Gosh, come on. And then just repeat. I'm not doing it again because that's way too many to cut and way too many to write on. You should have it by now. And remember, the first time for the orientations will be the plus 1/2, and the second time is the -1/2 for the spin number. Okay, so you make for sure you got this and you can do this, because if you can't, you're going to be hurting